So we're going to be solving a first order linear differential equation here using something called the integrating factor method. So our equation here is going to be, this is taken from this equation that BPRP used on his video, so I'm just going to be right here. Cos of x dx times dy over dx plus sin of x times y equals 1. So the integrating factor method basically says that we want to get this in the form of dy over dx plus times p of x. So basically some function of x times y is equal to some other function of x. So these two functions here should only be consisting of one. It should be only consisting of one variable plus the constant. So to do that, we're just going to divide both sides by cos of x. That's going to get you dy over dx plus tan of x times y is equal to 1 over cos of x, which is just secant x. Now, what we're going to do is our integrating factor, which is we denote by mu of x, is equal to e to the integral of p of x dx. So our p of x here is tan of x, so you're going to e to the integral of tan of x dx, and if you memorize your integrals, this is basically equal to the integral of tan of x you could either denote by negative ln cos of x, but if you just bring out the one here, it's just ln of secant of x. So this just becomes, and we don't really need to bother to see here because we're gonna be having the seen then. So it's just gonna be equal to secant x because the ln and the factor. So that's our integrating factor. So we're going to times this whole new equation we have here by secant of x. So we're going to get secant of x dy over dx plus secant of x tan of xy is equal to secant squared x squared x. Then we're going to be basically we're going to say that the derivative of our integrating factor, which is we had secant of x times y, is equal to the integral of this right side here, which is secant squared, sorry, not the integral, yeah, you don't do the integral, yeah, secant squared x. Then we're going to integrate both sides with respect to dx. So this is going to get you, these just cancel out, so this becomes secant x times y is equal to the integral of secant squared x is tan of x plus c. If you memorize, you could just say the antiderivative of this because tan of x is derivative of secant squared x. So we're going to have to get y in the end, so we're going to divide both sides by secant of x. So you get y is equal to tan of x of secant over x, if you think about that sign, over cos times cos. So that just becomes sine of x plus c over secant x, which is just c cosine x. And that is how you solve a first order linear differential equation. Thank you for watching.